Good afternoon. I'm gonna get back to work here. It's been a couple days. Oh man, so where were we? I'm trying to figure out how to finish off this flow field stuff, which we've been working on for way too long. Hello, Chris Goku 2. What is up? I am back from fishing, and that means back to work. So I'm just building the editor with everything that Adam's been working on, which is more assets, it looks like. Let's see. Looks like materials, post-process, foliage meshes, cavern stuff. Alright, so we got all sorts of new cavern stuff. But I'll be trying to finish off the magnitude stuff in this flow field. Like, we've got the directions, but it looks like I need to just go through these steps. So the shore needs to write a small number for a constant magnitude. Then we're going to go through with their starting magnitude. From the source input they spawn, particles. Alright, so we need magnitudes on the shore stuff. I mean, on the paths. Reading a graphics book? What? Books are for chumps. What I usually find is a lot of advanced graphics techniques don't really take reality into account because they're always using something like new and that can't run on like pretty much any machine. So like you go to GDC or something and you'll see all like these cool demos. They'll be like, "Ah, this is so amazing. This is gonna be the next biggest thing." You know, like, oh my god. And then people are all fawning over it and you're like, well, how many machines does that work on? Oh, you know, like 5% of the market. And you're just like, alright, thanks. Next. Hello, Frosty Has. How's your horror game going? Let's see. We are looking at what's the material we're using for this. I need to double check it. The specs always confuse me. Yeah. Alright, so what we're doing is we're taking this texture, we're taking the alpha channel and putting it in the gray. So the alpha channel on this guy is going to be the alpha channel of this texture, which is blank, but you can see a little bit of the alpha if you really use your imagination. Just in crunch time now? Yeah, that's one thing that I'm trying not to do is crunch a whole bunch on this thing, because you can work real hard on stuff, but like the game is going to take as long as it takes, and if you kill yourself for it, I mean, you do need to finish games though. That's one thing I've seen that people don't. Like you can be good at developing games, and you can also be good at actually shipping games, and they are two separate, distinct skills from each other. But yeah, sometimes it's necessary to just get it finished. But yeah, good luck there, Frosty Has. Try not to kill yourself. I think there was that one article that was recent. These guys had been working on a mech game or something for years and years. And it just like, the guy charted his health or something through it, and he became an alcoholic, couldn't sleep. The doctor was like, Jesus Christ, dude, your vitamin D levels, do you live in a cave? And he's like, I live in, yes I do. So try not to, more bothered about getting good reviews than sales. Well, if you don't get sales, you can't make the next one. Or at least it doesn't always, you know. Makes it less likely. But yeah, good reviews and all that stuff. That's one of the things that, like, one of the reasons I'm working with Adam is because I've seen, like, one of my friends put out Pixel Sand recently and stuff like that. Some of my other friends worked on mobile games like Dino Walk Simulator and other small games that are kind of fun. But just marketing is everything. Like if you don't have any marketing or brand recognition or something, it'd be like, it wouldn't even matter if you had a good game. Nobody's gonna care. Nobody's gonna ever see it. Alright, so I need to figure out what I'm working on here. Are you looking, Chris Goku, to how much of like vertex buffer size, or are you talking about how much memory it's got? Because getting reliable specs from like any API calls or anything are actually, it's pretty difficult to do, because everything's different. So you kind of gotta fudge that. Well, probably what you want to know is how much video RAM your graphics card has, and then kind of figure out how big your vertices actually are in memory that gets shipped to that thing, and then just do the calculations. Because as far as I'm aware, getting like actual specifications off of your card is pretty much impossible programmatically. You pretty much have to go to the datasheet on the actual card and read whatever they wrote. Yeah, that's the other thing. Just run it and find out where it blows up. Alright, so I'm going to try to focus here for a second and actually get started on doing something. Alright, so I need to figure out where I'm actually writing the alpha channels out. Yeah, Chris Coca too. Honestly, sometimes the easiest way to find that information is to just write a program which shoves data into the vertex. You know, just see what happens. See when the frame rate takes a catastrophic leap from like 300 frames per second to like 2. You're like, aha, this is where we're out of memory, and it's doing ridiculous things to try to continue processing what I'm passing it. Good afternoon, Karakan. I am back to doing actual work. I need to kind of wake up here. I'm just kind of blah at the moment. Alright, I think this tiered average stuff. Alright, so we got that. Okay, writing our flow objects. Alright, here we're actually generating our flow field. So first thing we do is write our short edge. Alright, and we're going to set a small magnitude for everything here. Okay, so we did that. And that's going to be our passed in magnitude. Was blah the whole day yesterday? Yeah. I was out in the middle of a lake fishing with my dad yesterday. In the middle of like, 96-degree weather. So I'm a bit fried at the moment. Alright, so we then write our calculated paths, and our path writes in the particles. Alright, so I'm kind of going over these notes that I've got, so kind of these steps that are actually occurring. So we're going to write in the paths, and we're going to write the magnitude of that path. Well, it looks like I need the actual path set on the... I need the magnitude set based on the path. So I probably also need the shore edge magnitude to be set by the actual asset. Okay, so let's do that. Alright, so set the shore weight. Not the shore weight. The weight is different. We want the shore magnitude. In Blueprint, we're going to want to set the the flow path magnitude and blueprint and pass that in. Alright, so let's do one after the other. Got a solid sunburn. Well, then you're doing it right. Well, I don't think I got a sunburn at all. Since, like, you know, we're out on a boat, so I can at least shelter under the small covering we have. And I've gotten a lot better about not getting horribly burned when outside. You know, things like putting on sunscreen usually helps. Alright, so we're going to do the magnitudes for this flow field. And then once the magnitudes are done, we're going to need to run through a couple of different scenarios, make sure this thing actually works. We might need to clean up the code, and then we're finished with gathering information for our water. We'll actually be able to maybe start working on the actual water. Alright, so we need this blueprint to have the shore repulse weight. Let's see what we've got here. We've got shore blur, max depth, flow field generation. Generally just even with sunscreen. Yeah. That's like with me, I don't actually get tan at all, I just get more freckles. That's it. Okay, so we have our components here for debugging. Flow field generation. We've got our paths weights. Why don't we make a new thing here? We'll call this, this will be our magnitude, so this should be like our water speed. Let's call this shore water speed. Turn this into a float. Let's just put this in category of speed. Let's give it a default of 1. We'll take it from 0 to 10. Alright, so we'll add that. We're going to need to pass this information in somehow. I think it's going to be this set full field gen. This set full field gen parameters and m shore water speed. Something we'll need. So let's go ahead and set this up. Set flow field gen variables. And we just have like a whole bunch of garbage here, and we're definitely going to clean this code up when we get more on board with it. But for now, I'm not going to worry too much about it. Alright. Alright, Frosty has. Take it easy. Or don't. Get your game finished. Go have some fun. Alright, so we got the shore water speed, we got that going on. Now we're going to need the flow field stuff to actually have it on there. So we need this flow object. Let's see. The flow object has get weight. Alright, so get weight is actually going to return what we need, I believe. So we have the weight in here. And the weight is the speed. So we've got that at least. Alright, so we got that. Then what we can do is close this down. And we can set our magnitude in here. let's see, where is this? So the right calculated paths, right particles. So okay, so for every path in paths, we're going to need something. Do the paths actually have the weight attached to them? We've got the input and output nodes. So we're going to want the Are we going to want the speed to be based on just the input? So if you have a 10 input, it always does 10 output? Or should we take the inputs and the speed is based on the number of outputs that it has? Or should we just have constant speed? I mean, one is more realistic. One might be easier to actually use. Probably just want to keep it constant, just because it'd be simpler. Your GPU has game development mode? So it's got like extra debugging stuff that might be available if you're like running pix. Alright, so we're basically looking at pixels subindex.mag, and we're gonna, I think what we're gonna do is we're always going to set the magnitude of this thing to so I guess the magnitude is going to be we can set it to the weight here, but I'm thinking about when we write the magnitude to the flow field, maybe we should always write the maximum. Kind of like that. Yeah, maybe this will work. Alright, so we have the weight getting set. We need to go ahead and build and pass in this thing. It's not yet. We need to make sure we actually write the shore edge magnitude stuff here. Edge radius, shore mag. Let's see, we wanted to actually put in the shore water speed. Like that. Because I'm trying to think right now with the magnitude, if, I don't know, it's not directly tied to the direction. We might get some weird stuff going on. I think we got enough noise here, though, that it doesn't really need to be correct. So maybe we just need to get an approximation. And if this doesn't work, I can go back and kind of mess around with stuff. Okay, so we write in the paths. Alright, particles need to know their starting magnitude, which is the source input they spawn from. Well, let's actually just build this and hook up the shore magnitude variable properly in Blueprint so I don't forget about it. So it is what, the first day in August? Man, it feels like, only yesterday I started working on this project. So it'll be 7 months of work. Gosh, yeah. Well, we put a huge hole in our schedule because of the graphics stuff and the look that we're working on. Taking a lot longer than we thought. Otherwise, right now, I would have been working on UI for the level. And that means I have been working on the look stuff as opposed to gameplay for 6 or 7 weeks. Alright, so we got the shore water speed there. Let's snag that and throw it in. Alright, so we got the shore edge working. So let's make sure we got the rest of this going on. So write the calculated paths. We have the path flow weight times path magnitude. Okay, now we're going to need the write particles to flow pixels. So every one of these things needs a magnitude, which was their initial magnitude. I said they need to know their starting magnitude, which is from the source input they spawn. Particles without input need a small constant magnitude. Alright, so we're going to need m random water speed. So we'll get that going on here. If people were curious if we actually caught fish, we did catch fish when we were out there. Just not enough of them, so I let them all go. Because at some point you're like, well, you know, there's only like a couple fish here or whatever. I don't need to murder all these for a meal. And I already have some fish, and you shouldn't eat like so much fish out of lakes and rivers and stuff like that because you'll die a horrible death. There's just, you know, because mercury poisoning, heavy metals and things like that. You know, it's good to eat things out of not lakes and rivers that are fed by runoff from mines and other sources of pollutants. Alright, so we've got our small water speed. Excellent. Alright, so when we write a particle, when we create a particle, we're going to need to know if it was spawned from a path or not. So we have a radius of, this is the object, we need a particle. We have pos, velocity, dx, dy, initial direction, we have initial mag. Oh man, look at that. I'm copying these. Alright, so this will be particle at m initial mag. Alright, so we'll have float initial mag. This will be random particles per frame. Alright, this one's going to be, this is for the path. This will be path.m input. Dot m wait. Alright, down here I'm just gonna say like -1. He'll die a horrible death anyways, as will we all. I don't know, Karakan. We just need to hold on long enough so they can upload our brains into the machine, and then we'll be good. Alright, so we're gonna spawn the particle. Particle is going to have an initial magnitude, which we need to set. Alright, so I think we got that going on. So let's see, which function am I looking at? It's going to be this write particles to flow field, source particle, text.direction. Okay, so for every particle here, so we want the actual particle. We're going to have, yeah, it's going to be float. Pmag is going to be particle.m initial mag. Alright, so if Pmag is less than 0, then Pmag is going to be this random water speed. Infinity does sound pretty boring. But what if you could just like take a potion and forget everything? You know? Then would infinity be boring? You'd exist forever as Dory the fish. Alright, so we got our magnitude. I think we want to Pmag times equals this passed in particle magnitude. And do we also want to give like the historical stuff here? I should probably restart and actually, you know, apply Windows updates at some point around here. But why would I do that? Alright, so we have the path, the pixel direction. I think I'll just see what it looks like as it is. And that should be okay. And then we need to write the particles to the magnitude field. Blur this field using the tiered hierarchy. Do not overwrite the mag already written. And alright, so we need to do our tiered hierarchical blur. You'll take Oblivion, thank you very much. I'd rather not exist than exist in perpetuity as a happy fish. I see how it is. So write the flow field objects themselves to the pixel grid. Alright, well these objects, the actual objects, alright. We can write the magnitudes directly, or should we just write the maximum mag? I think we will. Alright, so this is going to be the object.mWeight. So, but yeah, fmathmax. So, Karakan, are you one of those that avoids sleeping because you think that when you close your eyes, you actually die at night, and then you come back the next day, and it's just the same. It's the same sack of chemicals that has the same memories. It's just but it's not really you. So we have the magnitude written out here for the flow objects. The flow objects should be good. So now we can go back to the tiered average. All right, the tiered average is going to calculate our averages. We're going to write our pixel. Alright, so we write the magnitude in there as well already. Let me call post process, and the magnitude is going to be scattered out. Let me go through and we say equals mag get info. Does the get info actually get the magnitude? This tiered magnitude doesn't really make too much sense. I think this one should pretty much always just be 1. Okay, then we have the rough blur radius and the fine blur radius. And we're blurring our magnitude already. So theoretically, we're pretty much there. So let's take a look at this and see what we get. Try to spawn particle does not take 8 arguments. Let's see, what is this? Ignore flow field direction. Alright, so we have x, y, dest x, dest y, flow field, if we should ignore it, the direction, and then the weight. This should be correct. Did I not add the weight on the end here? Yeah, there we go. Float. What did I call that? Initial mag. That should be good to go. Alright. Hello, Synchron. I am working on the magnitude field stuff that we were messing around with last time. So it's getting we got the directions all working properly. We're now going to get the speeds, the water speeds in there for the flow. I'm kind of doing them disconnected from each other a little bit. And we'll see if this works. I'm not really sure what this is going to look like. Because when I was thinking about all this stuff, like, it gets pretty complicated pretty fast. And sometimes when everything is... Sometimes when things get complicated, it is not always the best decision to try to solve them properly. Sometimes it's better just to kind of approximate it. At least, like, it doesn't have to be correct. I think the best example of this is we had to write like some bump mapping stuff in graphics class at one point, and I had written everything in DirectX and HLSL for my game, and I had bump mapping like for the year before. So it's like I already know how to do this, and then we were supposed to, like, in graphics class it was all OpenGL though, and I was like, well, OpenGL's for chumps. I'm not gonna rewrite this. So for my assignment there for bump mapping, I just like threw a bunch of math in there and then just like added the normal map to the lighting vector and just like averaged it, and just that's actually what it did instead of taking like tangent space normals. And it took me, just like 10 minutes to bang this thing out and just submit it. And it looked correct. It looked like bump mapping because it did stuff based on the normal map to the actual surface. But it was all just trash. I called it addition mapping. And it was really funny because I got 100% on that assignment, and one of my friends that had actually done the assignment properly with the actual real math got like a B on it because he actually had the actual math in there. So when the person grading it looked at it, they actually understood what they were looking at and were like, oh, well, this part was wrong or something just by like a little bit, and gave him like some negative points. Versus, he looked at my math and he had no idea what the hell he was looking at. So he's like, all right, I'll just look at the render of the thing, and the render looked proper, or at least close enough to good. And he's just like, whatever, 100%. I don't give a shit. And what's the moral of that story? I really don't know. Probably that cheating pays off if you don't get caught, and cut corners where you can, because it doesn't matter if you try real hard, you'll get screwed anyway. Welcome to life. Yeah, so he was like, I don't give a shit. Yeah, that was the funniest thing. Is like, and of course, my friend, I was writing, this like piece of crap implementation of it right next to my friend who's doing the real one in like the computer lab, and he's just like, dude, you're gonna get a really shitty grade on that. And he's like, I don't, I'm like, I don't give a fuck, like. And then of course we get our grades back, and he's like, what the hell? How come you got 100%? All right, so let's make sure we actually got everything set up here. So we got the tiered average, we've got the blur, we've got the other blur, we have all these things. Do we have a max magnitude? Max magnitude we're just setting to 10. We're setting it inside of our flow field gen variables. I think our max magnitude should be determined by our actual maximum magnitude or something, as opposed to this crap. So why don't we actually keep track of it? So like m max magnitude equals 0, and then we just determine what the maximum magnitude is. Why don't we just do that at the end? Just, who cares? We're already iterating over everything a million times already, so what's one more iteration over every goddamn thing in the entire universe? That's what I think. Alright, so that'll be that. And let's change this so that we never set it. And this will probably screw all sorts of crap up. But I'm not super worried about it. So let's get our max magnitude. Let's make sure we can actually snag that out of our object. Let's see, get max water speed. Float. We'll snag that. Because it's important, we're going to need this for our shader to actually draw proper things. Because we're going to, in our shader, it's going to go from 0 to 1, but we're going to need to know maybe the actual maximum water speed. Alright, that's the spelling. So the Z buffer is basically a what it doesn't describe. You should patent your addition mapping. I assume it has better performance. Well, of course it does, because it doesn't do anything except just do a texture lookup and then add it to, you know, another vector and just like figure it out. Guild Wars 2. Well, one of my friends worked on Guild Wars 2. So. Actually, several people at Amazon were part of ArenaNet, and a lot of people from the college I graduated work on Guild Wars, so it's a good game to waste all your bandwidth on. Yeah, the Z buffer is what? The depth buffer, so when it's writing pixels, kind of standard graphic stuff. What college did I go to? I went to DigiPen. Its name is as dumb as it sounds like. It's literally DigiPen, as in digital pen. Let's see. So yeah, the Z buffer, kind of how it works is, you know, you're drawing rasterizing pixels to the screen, and rasterizing triangles, drawing these pixels to the screen. You write the depth buffer, and if you're writing, you write your depth and you write your color, and you check the depth when you write to see if you can actually write your color and stuff like that. Kind of, that's one way to use it. You can do other things, of course. That's why transparency stuff gets really screwed up with depth buffers, is because, like, what depth is the color if you have particles on top of each other that are, like, changing the color? Like, what actual depth does that color have? Does it have the last particle written color on there? But that's not really where all the color is coming from. So depth buffer stuff can get a little complicated with transparent crap. Which is why you'll see, like, transparent stuff actually has to be depth sorted before you draw it and stuff like that. Alright, so we're supposed to construct our static flow field, then we're supposed to call tick, and then we're supposed to call generate flow field. Actually, no, I need to fix the blueprint first. So I guess I just have to wait a couple seconds here. Yeah, when I went to college, it was like a small college. I think there were about 500 people total in the entire thing. Alright, so water flow magnitude. Okay, so it kind of fixed itself. And this was water flow mag. Is this even used? I don't think so. Alright, cool. So you're learning programming, or have learned programming through online stuff. I don't know, online stuff for me, at least for programming stuff, I mean, sure, you can do it, but it's really about working with people who are right next to you and talking about stuff and drawing pictures on whiteboards and having conversations. Alright, so we've ticked it, so if we generate our flow field... Ooh, okay. Looks like everything got written to 1, which is not super great. Max magnitude is 1? Really? Looks like everything got set to 1. Well, obviously we have a massive problem with that. Alright, well, let's just make sure that we save everything. Yeah, as far as I saw, at a certain point of education with programming, I'm just going to go through each one of these steps and verify that it actually does what I want. At some point with programming, I think education kind of goes out the window and you just have to sit down and work on stuff. Yeah, there's all sorts of stuff there. Yeah, I find a lot of more special instructions and stuff like that. That kind of harkens back to development of 10 years ago in a lot of ways, or development more than 10 years ago, because special instructions and everything else have kind of gone out the window on stuff since like big engines like Unreal and the rest started coming out, where if you're working on a game, like for you to actually be doing crazy stuff that requires like a whole bunch of special instructions and everything, it means you're not releasing on a whole bunch of different platforms, stuff like that. And or at least the thing you're working on isn't going to actually be on all those platforms. Alright, what is this garbage? So when I'm looking, I think I'm not looking at the proper variables, because this is the texture, which would appear to have, ones around all these things, which is proper. But what we're looking at here on the material is not proper. So it's like the material doesn't have the alpha channel. Yeah, the material doesn't have an alpha channel. The emissive color should be from 0 to 1. I would expect this color to be 0, though, which should be black. Yeah, it's kind of one of the things, like, you can make a console that has like all these specific instructions and all this stuff theoretically to make it better, but like for the PS3, one of my friends worked at a company that Electronic Arts would basically ship its game that worked on Xbox and PC to this company, and this company's only job in existence was to take games that people had already written and make them work on PS3 and stuff like that. Which is just, if that's the point, that, like, if that's where everybody is with writing code for your project, like, then, like, you have massively failed when you've created your piece of hardware. Pause.y. Alright, so let's get this printed out. Linux is good just in general. Like, all the server stuff I ever wrote was pretty much like we wanted to run on Linux because it's cheaper. So, like, knowing how to use Linux and all that is a really good idea. Not so much for game client development. Kind of, the markets are much smaller. Yeah, and if there is an API, or an API comes into existence and is available for your language, I would really expect, your compiler developers to really be hammering on making that better. Because there's only so much you can do as a developer to specialize your program, and unless you're writing, ridiculous things that are only going to run on one piece of hardware, that level of specialization I just don't see happening. So a lot of those instructions, it's good to know they exist and things like that, and be like, oh, well, you might be able to use this if you have this special problem, like if you need to generate a whole bunch of light maps or something for your development studio, and this is all statically computed, you can just have like a machine in the corner that has the correct stuff on it, and just let it do its thing. So what is all this? Max is 1, 255. Everything is getting set to 1. I mean, so what the fuck? Alright, right shore edge. Alright, so for every pixel, It's really, it is crazy. Alright, so which part of this is actually setting this thing? It's gonna be, alright, so we're not setting this inside of the constructor for this thing, right? Like, we don't even have a constructor for this. Yeah, the mag is getting initialized to 0, so we must be setting it here. We must be setting our magnitudes somewhere here. Oh, well, it's going to be right here where we screwed up. It's mag times shore speed. It's literally supposed to be this value. We're doing pix. We're not doing pix.mag. Alright. There we are. We're all doomed. I don't know. I think what Xbox has been kind of trying to merge Windows 10 and everything else. The only reason I could see anybody trying to do gaming specializations would be to get virtual reality stuff going up and running. That's the only place where I think people might actually invest the time, because a lot of VR stuff is very experimental. So having specialized instructions is a good idea a lot of the times, because you're only going to be going after a certain collection of hardware anyway. You're probably not expecting to make a whole bunch of money, and those special experimental things might become the new standard if they actually work properly. What is this special CIA API inside of the new Xbox? Yeah, what is this? Pound include nothing to see here.h? I don't understand this. We're not writing the mag in here, are we? There we go. And that's kind of some of the interesting stuff there is, if a lot more of the development is going to be taking place inside of, non-super low-level programming environments, such as, in your C++ and blueprints and visual scripting languages.